This video is to show you how to use the equipment for experiment K4, which is a plug flow reactor, and you'll be investigating the inversion of sucrose. Now, this reaction, in order to be doable at the lab timescale, has to be done at about 60 degrees, which is not scalding hot, but it is fairly warm. And in fact, the slowest thing that happens here is you have to get the reaction water up to 60 degrees. Now, the hot water bath will have been turned on before you get here, so it should be at 60 degrees, but the solution that you're going to be using is something else. So we have a water heating device that you've probably already seen. It's a kettle, and because you're going to be heating reactant, it does need to be filled with distilled water. So fill the kettle up to 1.7 liters, which is the maximum, and bring it to a boil. And then pour that, this is actually cold water, but you should be using boiling water, into a beaker. And you need to have about 2.5 liters of about 65 degree water. So have another beaker of room temperature distilled water, add it, and stir with a thermometer and check what the temperature is, and keep adding until you get to about 65 degrees. So you would check that by stirring it to get it uniform and check the temperature on the thermometer. Let's assume I've got this to 65 degrees and I've got more than 2,500 mils. I'm going to use this beaker as the vessel for the solution. I'm going to empty this now, just distilled water. You're going to need to measure out 2,340 milliliters of warm water, which you're then going to dissolve sugar in. So using a graduated cylinder and the beaker of about 65 degree water, it's going to be warm but not unpleasantly so. And using the graduated cylinder, you need to measure out 2,340 milliliters. I'm not going to do that completely, but there's 500 mils. Yep. Dispense that into that beaker and keep on going until you've got 2340 mils. Once you've got the appropriate volume, this goes directly into the hot water bath, and it will come to the right temperature fairly shortly. Now at this point we need to add some sugar to get that into solution. You should weigh out 60 grams, which adds to 2340 to make 2400. Just pour this directly into the beaker, and you can use your thermometer to stir that around. Now with this being 60 degree water, it's going to dissolve fairly quickly, but you do need to make sure before we do some reactions that it is in fact all in solution. All right, that's the solution that is going to be reacting now. We now need to get the reactor busy. We are providing you with 2 reactors. Just get one here. They're both condensers, and this one you're going to be filling. The 2 of them have slightly different central cores. One is narrower than the other. But this is normally a condenser. You've seen them on microscale already. We will fill it an appropriate amount with the catalyst, and then the water jacket, which is normally used to keep it cool, we're going to pump 60 degree water through it so that the entire reactor is also at 60 degrees. Putting that to one side, because the actual packing process takes a while, we have provided you with one that is already packed, and then you're going to pack another one for the second half of the reaction. Let me get the clamp stand here. The reactor that's already prepared is actually in this trough. It's stayed underwater. One of the problems that we have is the reactor bed needs to stay wet all the time. If you let it drain out, you get pockets of air in it, which can really badly interfere with the way the liquid flows through it. So you do need to keep it wet, and this one has been underwater since the last time it was used, so of course it's going to be wet, excuse me. So the reactor bed runs from here down to here. You'll notice there's some cloth at the bottom through which liquid can flow, and it's held in place with a hose clamp. We put a cap on this so that the water and the resin doesn't flow out. We'll take that out in a minute, but we're now ready to put this next to the hot water bath. Now, we need first to connect the circulating water, and to do that you need to turn the hot water bath off for a bit, and one of these you will have seen water flowing out. So you put the one that's flowing from the bath, connect it here, and the other one you connect to the top. Now, to make sure that these don't pop off, they have got hose clamps on them. And you put that over the rubber tubing so that the glass is underneath, and using a simple slot screwdriver you tighten this up, and this will hold the tube in place much more firmly. And there's one down here to do with the feed one. Okay, whoops, and tighten the hose clamp again. You don't need to have it horrendously tight, just until it's firm, and that's probably good enough. All right, now at this point you can turn the water bath back on, and you notice that the water which was shooting back into here is now filling the jacket, and that will keep the reactor at 60 degrees. It'll take a while for it to get up to that point, but while we're doing that, I'll show you about the pump. This is a peristaltic pump, meaning it works the same way that your guts do actually, and it's a tube with a roller that pushes the liquid through. There are two ends to the tube, of course, and the free one goes actually into the reaction mixture like that, and the other one goes to the top, and this is going to go into the top of the reactor. Now, the control for the peristaltic pump, and you can have it go one way or the other, and you can control how fast, is right here. The switch is in the middle is off. When you push it down, it pushes the liquid out of this tube. If you push it the other way, it will try and pump in the opposite direction. So do make sure that you've got water coming out, the solution coming out of this tube here, which is going to go into the top of the reactor. Now, because you don't want to flood the bench, first, before you take the cap off, put a beaker underneath so that it will catch the outflow from the reactor. Then we can, unplug. Because I've now broken the airlock, you'll notice it's dripping through quite fast. Take the output of the peristaltic pump, preferably not tangled up, place it inside the cap, and use some electrical tape to hold it in place so it's not falling off. And at this point we'll turn the pump on, and we've now got liquid coming up the tube and into the top of the reactor, and this will keep liquid flowing through for as long as the reaction needs to be taking place. Now, I need it to be a little faster than it is at the moment because I don't want this to dry out. So there's a blue line here. You want the level of liquid above the reactor to stay approximately there. Okay. So I'm speeding the pump up so that it's delivering more liquid as we go. That's got it. Now, it may be that you don't hit the right speed initially, and you have to adjust this during the run. That's not significant. As long as the height of the water column is approximately the same, the flow will be approximately the same through the reactor. All right, and now this is ready to go once you have checked that everything is at 60 degrees, and you now let this come to steady state. That will take about half an hour. And so, while that is happening, we will pack the second column. This beaker contains catalyst, and there's also a large bottle of it in your locker. The catalyst is actually, I'll take a little bit out and put it on here, it looks like brown sand. And if you look closely, it's little round beads. It's made of a polymer, and the polymer has charged species in it. And it behaves as if it is acid. It will release H+ for the length of time that it needs to. And this is your catalyst. Unlike a homogeneous catalyst, where you pour in some acid, once the catalyst in that case is in the solution, it's there. This catalyst only works when your solution is in contact with it. And so you can stop the reaction just by removing the catalyst in some form. Now, you will need about 20 grams of this, so just use your top loading balance, that's going to be accurate enough, and dispense about 20 grams. Well, actually, you want exactly 20 grams in this case. This is not a case where plus or minus 10% is okay. You want to aim for as close to 20%, 20 grams, as you can. 19.92, 20.00. All right, we are now ready to take this and place it in the reactor. One other thing you will need to do is you need to know the density of this material, because that's actually how you're going to figure out the volume of your reactor. So when you're doing that, fill the graduated cylinder, which you will have weighed, fill it to exactly 25 mils. Once you know what 25 mils of catalyst weighs, then you will know what the density of the catalyst itself is. So you'll need a dry graduated cylinder of about 25 mils to do that part of the experiment. Let's go back and now make the other reactor using the 20 grams of catalyst that we've weighed out. Now, this is the other condenser, and we're going to pack this so that it can become the second reactor. Clamping that in place, we'll need to put something at the bottom. You'll need a square of fabric. You can reuse ones, but if you need to, we've got fabric in the drawer and a pair of scissors. It's 9 centimeters square, and you need to hold it in place. So put it like that, bend up, wrap everything around. I realize that looks like origami. Take a strip of electrical tape and hold it in place for the moment. Now, this is not actually how we're going to keep it in place, but that'll hold it in place for the moment. Right, so that is now ready to go. A closed end that will stop the catalyst from falling out. We now take another hose clamp and place it around the bottom and tighten this. This is actually quite loose, so I'm going to need to do a fair bit of tightening here. But because the fabric and the electrical tape are a bit squashy, they will act like an O-ring, and you compress them with the hose clamp, and that will form a tight seal around the bottom of the reactor, and that is now going to hold everything in place. Now, we're now ready to take the catalyst and pour gently into the column, or reactor as it's going to be. You can bend these weighing boats, which makes it easier to pour from them. There we go. Come on. Try and get all of it out. But this is only top loader accurate, so if you've got a few left over, it's not important. Now, this is dry, and it's considerably shorter. The shape of the reactor is not consistent, so we can't actually determine the volume except by knowing how much catalyst is in there. And so knowing the density, we'll know the volume of the catalyst and therefore the volume of the reactor. At this point, I need to be filling this with water so that it can become ready to react. Put something underneath because it will immediately start to drip, and just pour some water in. There we go. Now it will take a while to make it through, and sometimes you will get air gaps coming. And to eliminate those, just tap. If you see bubbles or light silvery colored areas, that means that there's an air block, so tap this to get it out. Sometimes, this one actually has worked quite well, you don't need to do too much tapping. Sometimes if you're unlucky, it'll take a little longer. So that's why we provide you with one pre-packed. Now you'll also notice that this is flowing out fairly fast. So you do need to keep the reactor wet once you have started. So just pour in water and make sure that you keep that topped up as long as you have got this reactor ready to go. All right, now I'm going to put this to one side and talk about taking readings. Let's assume that this reactor is almost long enough. Now notice that I've actually got rather too much water in here, so I can slow the pump down. But do keep watching to make sure that there's enough liquid in here all the time. I do need to have an idea of how fast the water is coming through. So with a timer or your cell phone stopwatch, for a controlled period, say 3 minutes, put a graduated cylinder under there so that you know how many mils of water runs through the reactor in a given period of time. This is probably going to be 2 minutes, would give you a decent volume. So you need to do that at some point in the half hour while it is coming to steady state. Once you are at about 30 minutes, you'll need to start taking readings. Now you're going to be determining how much of the reaction has proceeded using a polarimeter, which reads organic compounds such as sucrose that either left-handed or right-handed rotation of polarized light. The polarimeter will actually be on the other bench, and there is another set of students, people doing experiment K2, who will use it all the time. So please pack your readings in around it rather than keeping them away from reading it at an appropriate time. Now let's fish out the reactor, the polarimeter tube. Optical rotation, it turns out, is a function of temperature. So you need to read it at 60 degrees because that's what the temperature of this is. So keep the cell inside the hot water bath and only fish it out when you're just about ready to go. It holds about 10 mils of liquid. Now it will be warm, but not uncomfortably so when you take it out. Now towards the end, once you've got about 10 mils, and I should have changed this, whoops, stand that up, trade this so that we got something happening, and fill the reactor. You don't want this over the top, but you do want it as full as you can reasonably get it. And that's okay. Now put the cap back on. This tube is exactly 2 decimeters long. Tighten it. There will be a bubble, but if you notice, there's a bulge in the glass. And so you tip it until the bubble is actually in the bulge, and that means you've got liquid from one end to the other. You need to make sure that you do have a clear run, and so look through the tube until you're sure, and if you can see the pattern of the bricks, then it's ready to go. This one isn't, because I've still got wetness on the end. So take a paper towel and blot both ends, so once they're dry, and once you peer through it, you should see clear images, the grid of the brick, and this is now ready to read. The polarimeter, you just put the thing inside the holder, wait until the numbers calm down, and that is your reading. Don't touch this other than that, because you'll upset the readings that the other people are doing. So just put it in, take a reading, and take it off. If there's no one actually using a polarimeter the same day as you, your TA will teach you how to use this. Anyway, once you have finished this solution is now garbage, and you can pour it out. Put the cap back on and pop it back in the warm water bath, ready for the next reading. Now, you need to have 3 readings consecutively that are within 10% of each other, and that will tell you that the system has reached steady state. It's probably for this reaction about 5 or 7 minutes apart. So once 7 minutes has passed, then collect some more, refill the sample cell, and read it again. And then discard that. The reaction is continuing, and take another reading. You'll need at least 3, and if they're not settled down, keep going until you do have 3 readings consecutively within 10% of each other. Sometimes that takes 5 readings, 6. If you're lucky, it'll be 3. Anyway, once you have got 3 in a row that are finished, you are finished with this reactor, and you're ready to move on to the next one. So let's talk a bit about changing over from one reactor to the next. First thing to do is turn off the peristaltic pump and remove that tube. We'll also need to, whoops, where is my screwdriver? There we are. We'll need to turn the pump off first. If you don't do that when you open this, there will be water spraying everywhere, which will be very amusing to the other people, but not very amusing for you. All right, so just leave the hose clamps actually on the hose, and that will help. Once we've got these out of the way, then there will be some water flow out of the condenser jacket when I open the tubes. Pick that one and just pop it over here and unclamp this for the moment so that when it does spew it'll be okay. There we are. And that's the outflow, so it'll, the input. And then put this back in a clamp and get it the heck out of the way. Again, for this one, you're going to need to add water to it to make sure that it doesn't dry out. And we'll talk a bit about cleanup in a minute. Put the cap on and leave it until you've got the next one set up. But do put a beaker underneath because it will tend to drip. We'll now bring the column that you packed over and place it in exactly the same place. And you just set this up in exactly the same way as you had before. Put the inflow into the reactor, and again, hold it in place with electrical tape, and reconnect the heating water tubes. There we go. And you'll need to reconnect the hose clamps. And once you have done that, you can turn the water bath back on, and this system can then come to thermal equilibrium. You'll need to leave it for a few minutes because the stuff inside is not at 60 degrees. Oops, should have had that underneath. So turn this on. There we go. And that's now got a 60-degree jacket going. Keep water flowing through this. There we go. To make sure we don't have, see, I let this get dry, and can you see the silver parts there? That is an air bubble. So that's what you don't want to see. So you need to keep tapping until you get most of that out of the way. I'm not going to take time to do that right now, but you do have time until this whole system warms up. So it's at least 5 minutes to go. Then, once you are ready, you turn the peristaltic pump back on, and you need to slow it down. The previous one will have been about 10 mils a minute, probably. You want to slow that down to be somewhere between 2 and 6 mils a minute flowing through here. And that will not have a constant fluid level, but just keep measuring the outflow until you've got somewhere between 2 and 6 mils a minute, and then leave it at that state. Just leave the pump on at the appropriate rate, and that will let it get to steady state. And again, that's going to take you about 30 minutes. Once you've left it after 30 minutes, you then take readings, fish out the polarimeter tube, just as you did before, fill it with some of your liquid, and then read the polarimeter. You've seen that, so I'm not going to demonstrate that. While you are getting to steady state, you need to start the cleanup, first of all, with the first column, but it's now time to talk about cleanup for all of them. Let's assume that this is now finished. Oh, one other thing. As you continue pumping this out, you will find that the beaker starts to float because there's less and less weight in the beaker. If that starts to happen, just scoop some water out until the beaker settles down. Basically, it's so the level of water in the bath remains about the same as the level of water in the beaker. This hasn't happened to me because I haven't had it going for half an hour. But after about half an hour, the beaker starts to float. If that's the case, just scoop some water out, and it's just water, it can go down the sink, and we're ready to go. Let's assume that this is finished, so we'll turn everything off. The pump can go off. And what you need to do is get water to rinse this through. This one you pour, and you need to do this not just for a minute. You need to replace the entire water column, and you need to, at least twice. This is a sugar solution, and while it's completely unhazardous to us, it is yummy for bacteria. And if you leave sugar water in here, after a couple of days, it will start to go black and sticky because there will be bacteria in there. So we need to wash it with fresh water and continue doing that. You do that with this one while the second column is getting ready and you're reacting with it. So you can do this one as you're doing the second reaction. Once you have finished this, and I'm going to short circuit the process here. So this is not actually cleaned out, but I need to keep moving here. Put the cap back on and return the whole thing to the water bath, and that will be there for the next people doing this experiment. Again, once you have finished, you'll need to clean all of this up. So the first thing is place the pumping tube inside a beaker of clean water, and again, come on, pump liquid through here, and you need to have that going for at least 10 minutes to make sure that you've cleaned out the peristaltic pump tube. And that's not going to be very fast, so take the beaker and wash as well. Please make sure that all of the resin has been washed for at least 10 minutes of water flow in this case. Right, now I'm going to take this down. The peristaltic pump tubing needs to be disconnected. There we go. Once you have disconnected, like that, that goes back into the drain. If you open the top one, you shouldn't get too much spill. Remove that. And the water that flows out from that, put into this clamp so that if it does get turned on, the water is not going to shoot all over the place, but into the sink. Now, let's assume that I have washed this sufficiently, and what you do is pour it into a beaker. I'll need to remove this, the hose clamp rather. There we go. And this will just pull right off. And then you can pour water through it to get everything flushed out. Come on. Yeah, it comes right out very easily. Wash a little bit more to make sure you got everything out of the column, and then that's ready to go. This is water you can swirl around and decant. Decant meaning pour away from the liquid at the bottom. I'm using a beaker, but you can do this over a sink. Pour away as much of the liquid as you can, and then more water, swirl it around and dump, so that you're sure that this liquid, this resin, is as clean as possible. Once you have finished that, which will take a couple of rinses, and you've poured as much of the liquid out as is reasonable, there'll be a plastic tub for it, and you can dump the resin into here. It will dry in here, and it'll be used in future weeks, because the resin itself is recyclable. It's not single use. So, to summarize, you need first of all to get the water for the reaction hot. Then you put it into the water bath, take out the first reactor, attach the peristaltic pump, attach the circulating water, 30 minutes. Read, making sure that the cell is inside the bath for a good 10 minutes so that it's up at temperature. And you can read that on a polarimeter. Pack the other column, and when the first one is at steady state, set the second one up. For cleanup again, everything, absolutely everything, has to be washed out with water. And that includes the rest of your reaction mix. That needs to go down the sink and everything washed off with distilled water. And that is how you do experiment K4, the plug flow reactor solid catalyzed reaction of sucrose with an acid.